This question says the graphs of 4 mappings are shown below. So we have G1, G2, G3, and G4. Now question 9 says which graph is not a function? Now we all know a function is a mapping whereby each x value only maps onto one y value. Each domain maps onto only one range. And we can also apply the vertical test such that if the vertical line touches the graph only once, then it's a function. But if it touches the graph only more than once, then it's not a function, because that is indicating a certain x is going to more than one y. And to be a function, an x must only go to one y. So for example, G1, if you do the vertical line test, then the vertical line will touch the graph at only one point. So this G1 is a function. Okay. G2, if you do a vertical line test, the vertical line will touch the graph at more than one point. Let's take a closer look at it. For example, if you look at the x of -1, x of -1 is mapping onto a certain y value, and it maps onto another y value. Let's say the x of 0, mapping onto 2 and mapping onto -2. So for graph number 2, each axis, well, you have x's and x's that mapping onto more than one y, and that is not a function. So G2 is violating the rule of a function, so G2 is not a function. G3 is a function, the vertical line will touch the graph only once. G4 is a function because the vertical line will touch the graph only once. So the graph that is not a function is G2, because there are x's that maps onto more than one y. You see this particular x number 1, mapping onto one by, or y by up, and it maps in onto a y by down. So therefore now G2 is not a function. So therefore the answer is B. Because there are x's, for example, 2 mapping onto y by up and in mapping onto y by down, and that is not a property of a function. For to be a function, each x must map onto only one y. So if you have a particular x that mapping onto more than one y, then right away this graph is not a function, and this applies only to G2.